I found it!
What happened with this? I found one too here.
Wow, this tree may be infected. There is some fungi on top of the corn. Oh, okay. Let's bring it back to the laboratory.
Okay, we'll find out.
Good morning. We are students from Đào Duy Từ High School in Hà Nội, Vietnam, and today we want to present you our project.
By 2015, about 14% of agricultural losses were entirely caused by crop disease. Every chemical solution is still used widespreadly because of its high preventive effect. Thus, we want to find something that can replace the harmful solution. After researching, we now finally want to introduce you our project called Purification and Evaluation of Thermal Stability of an Antifungal Protein. Rhizoctonia solani and Fusarium oxysporum are two kinds of fungi may infect the crops negatively. The antifungal compounds are substances that have ability to inhibit or annihilate the growth of fungi, especially the antifungal protein was obtained after purification of bee subtilis from soil found in Vietnam. So I would like to talk a little bit about the Bacillus subtilis. It's a rod-shaped bacterium with high thermal endurance and easily create resistant spore. Our purpose of study has three main ideas. First of all, we want to determine the antifungal activity of the extracellular extract. Moreover, we want to learn about the purification of antifungal protein and also its evaluation of thermal stability.
Besides, microorganisms are needed materials, including Bacillus subtilis, Fusarium oxysporum, and Rhizoctonia solani. These are three environments we will use in our research: LB and YD BDA to culture bacteria and fungi to evaluate their active ingredients. Next, I will present the process of purify antifungal protein and make products from Bacillus subtilis. Following the steps, first one here is determine crude supernatant, and the next is fermentation of microorganism. After it was incubated at 30 degrees for 5 days, we got a fermentation broth. Then we centrifuge the bacterial culture for 10 minutes at 12,500 revolutions per minute to collect crude supernatants. Then dialyze at 4 degrees to remove the salt. The downline fractions were then applied to DEAE cellular column. Fractions with strong activity were continuously purified on BioCell B100 column. And after that, we used gel electrophoresis and measurement the protein concentration to examine purified antifungal activity.
The antifungal activity of the purified fraction was test against the Fusarium oxysporum and Rhizoctonia solani, and we use microscope to identify the purified fraction. And we also determine the thermal stability of the purified protein.
Statistical analysis is the last step.
And next we move to part result. First of all, we want to talk about the determination of antifungal activity of the extracellular extract, starting with the effect of crude supernatant from Bacillus subtilis on the growth of Rhizoctonia solani and Fusarium oxysporum. We can see that Bacillus strain has antifungal activity from 32% to 95% for the Rhizoctonia solani strains, and 35% to 93% for the Fusarium oxysporum strain, respectively. After determining, we purify the protein, and here are the results. The A is chromatogram showing the fraction evolved from the DAE cellulose ion exchange column. And here are the antifungal activity of the fraction we obtained. And next is the test of SDS page purified protein, and we obtained that our protein has the molecular mass of 40 kDa. After that, we can see the yield of antifungal protein purification from Bacillus subtilis is 10.7%. We use microscope to identify our purified protein, and we found that our protein was outer membrane protein. Last, we determine the effect of temperature on the antifungal activity for the Rhizoctonia solani strain, and we see that the outer membrane protein has the thermostable as it retained the activity when it hit to 100 degrees for 30 minutes.
I would like to summarize these following results. 50% of Bacillus supernatant inhibited the growth of both fungi from 93 to 95%. Secondly, the result of protein identification using mass spectrometry suggested that the purified protein are indeed outer membranes with 366 acid amine with a relative molecular mass of 39,360 Da. The antifungal proteins is heated at 100 Celsius degree in 20 to 30 minutes.
The data show that the Bacillus subtilis can be a potential environmental friendly agent to control the plant fungal disease. Our product was accepted by the Intellectual Property Registry. Thank you for listening to our project.